All right, I just want to do one example with you from section 6.6, and it's page 378, number 6 here. It talks about putting on these layers of this colored paper or plastic over a light, and it reduces the light. So we can see as the more layers get on, this lux measure, the light intensity, is decreasing. Now, one thing they tell us is that, we have to write an equation for it. So the first thing we have to do is figure out the equation. Now, it's going to be exponential. So when we start off with our exponential equation, A is the start. So when the 0 layers has a 431 measure in the lux reading of intensity, I just write that for the starting spot. So we need to figure out the B. Now, this implies that it's exponential. And what we have to do is find out what do we have to multiply each time here to get our next term. Now, obviously, it's going down, so it's a decay. To figure out what we multiply to get here, well, the easiest thing is to divide to go back. So I figured out a few here where I divide the 316 by the 431, and here I got a 0.73, or a 73% reduction, or down to 73%, which really is a loss of 27%. And here I did it with to figure out this multiplier, 233 divided by 316, to go back here, is a 74%. And I did it for a couple of more. Now you should do it for several here, continue on. And what we want to do is, we can see that it's different, it's changing each time, just by a little bit. So we want to figure out the average B value. So do it for several of these, and we'll figure out the average reduction ratio here. And here I got an average of about 74%. 0.74 is what I'm going to use in my equation. So here, upon finding that, I have my start value, and then I use my average ratio, average multiplier of 0.74. So here we have an equation where we can find out how many layers. At 5 layers, we can put this in right now and see what the light intensity is. So we can determine, knowing the amount of layers, we can exactly see how bright that light is, the intensity of that light. So here we have an equation. In B, it says, what does this R value represent? Now, one thing I want you to know is that another way to call this B value is R, the common ratio. And here we saw it as a ratio. A ratio means a fraction. So here we can see directly why they use the term ratio. So R is commonly used. So maybe you'd want to write your equation as y equals A times R to the x. R and B being the same thing, standing for that common ratio. What do we multiply by? And here, we've got a couple of ways to talk about what the R means. R being the 0.74, that common multiplier. That means that 74% of the light gets through each layer. So that's how much light is left or remains. Or we could say that we lose 26% of the light. So either 74% of the light remains, or we say we lose 26%. Notice that we're adding to that 100% total. In C, they ask, how far is it going to take for Phyllis here to get down to a measure of 30 lux? Well, the way to do that is check a few different values. Put in 7 and see if that gets us down. Obviously, we're not down to a lux of 30 yet. Try 8, try 9, try 10, and see, just take that, or we could multiply by 0.74, 0.74. See how many times we have to multiply by this 0.74 to get down, and we want to know how many layers is that. So try that